Excuse me, sir.
Yes.
Sir, there were some wrong answers in the previous assignment.
Which what wrong answers?
Sir, 1 minute, sir. Sir, question number 7 and 9.
Question number 7 and okay, I just have to open the solutions. Questions. Wait a second. Assignment 6. Is it 5 or
Sir, 5. Assignment 5.
7 and 9? Okay. What is the problem?
Sir, according to me, the answers should be different, I think.
In 7th, you need to find out the eigenvalues of A transpose A. Okay, so okay. Wait a second, spectral radius. They are saying it.
Sir, the spectral radius is the largest eigenvalue of the modulus in
Yeah,
modulus.
yeah. Oh, they I think they are calculating the eigenvalues, maximum eigenvalue of A transpose A in the
सरकार चुप क्यों है ये एनपी
okay, so I think okay. So what is the question asking about? Yes.
And the question is just asking about the spectral radius of the given matrix.
Okay. Spectral radius of a given matrix. And you know the spectral radius definition that it is the maximum of absolute values of its eigenvalues.
Yes, sir.
And yeah, so this is the spectral radius of a matrix. Yes. So what they are calculating in this, they are trying to calculate the square root of A transpose A. What is this? Wait, I just open a book and share it, maybe. Wait a second. Yeah, this the definition of a spectral radius is right. It's the maximum eigenvalue. Yeah, maximum absolute eigenvalue that we have already discussed last time. So the question is wrong, right? The answer is wrong in the question. So
Yes, sir. So that is the issue.
okay. Just email me, write me an email, and I will forward you the respective tutor. Question number 7 and 9, whatever. 7. What is the question number 9?
Sir, actually, I don't know your email, sir.
What?
I don't know the email of yours.
I have sent already before it. Why people leaving and coming again? I'm not admit everyone again and again. Yes. Okay, so you can see my videos in the previous. Let me write here in the chat box if you can
Sir,
see now.
I am unable to access the chat box.
Why?
Sir, I don't know, sir.
Wait, I will share the screen. You can see. Okay, let me share. Wait a second. I just opened the assignment before that. MATLAB.
Sir, please check the question number 9 too.
Okay. Wait, I just share this. Can you see the screen?
Yes, sir.
So we are here for assignment 6, right, today? Or 5?
Yes.
5 is done. Am I right?
Yeah.
We have done 5.
Yes,
Yeah.
yes, yes,
Okay.
yes. 5 so.
Okay, let's do the 6th one. Okay. Just see the sorry, I have not uploaded the last notes. I will do that. Okay, let me just okay. Okay, so what you are saying about assignment question number 9, right? Let me open it.
Yes, sir.
Wait a second.
The actual answer is none of them.
Question number
Yes, sir.
9.
None of the.
Yes. So what is the problem there?
Sir, the answer should be none of these, but answer is given something else.
So the question is, consider
Yeah.
the system of equations Ax equal to B where A equal to 1, 3A, 2, where A and
So
A
the
is a
answer
real
is
number.
C, right?
No, sir. No, sir.
Why?
So if for diagonally dominant conditions, if you are applying, the answer should be modulus of A is less than 1/3.
1/3.
Yes, that is
Sir,
the
if
correct
you
answer.
are considering
Yeah.
if
Oh,
you are
I understand. Yeah. That was a similar query raised by a student in the email, I think. He has sent me the email. Yes. So yeah, the question was wrong. So 7 and 9. Okay. Write a proper email explaining, and I will
And one,
forward it to.
sir, and one more doubt, sir, I have.
Yes.
Question number seven, not 7. Just a minute. Question number 2. Question number 2. Consider the following
Okay.
system of equations.
Wait.
Uh,
Yes. Question number 2. Okay.
Yes.
Yes.
Actually-
Using Gauss-Seidel method.
Yes. Actually, the actual answer is minus 0.7472.
Yes.
7472.
Yeah. Yeah.
Sorry, 7475.
Okay.
But it is not given. I choose the option none of these.
So they have ticked option number minus 0.747.
747 is not correct answer. The correct answer is minus 7475.
Okay. Yeah. So has it been written to round off or chop off? Is it written?
How can we take a round of another option? None of these option is given.
Okay. Yeah.
If the
yeah,
none
yeah.
of the option is
But
not
if they are
given,
giving like use just chopping off to 3 decimal places, then yeah,
it
this
is not
correct.
mentioned. It is not
Yes,
mentioned.
it's if
So
it's not mentioned, then yeah, it's none of these. Should be none of these.
none of these is the correct. Otherwise, in
But
the place
sir,
of none of these, if some other numerical number is given, we can possibly select 0.747 minus 747.
Yeah. Okay. So just
but
write
sir,
these.
if it is
Yeah.
nearer
What?
to our answer, then we can directly, we can directly choose the option. But because it is just near 0.7475, we can chop off it to 0.747.
Very good, very good. If the none of the option is not given, if the none of the
Yes,
option is
but
not
if
given,
none of-
suppose if it is not
yeah.
none of the option is some other numerical number, we can choose 0.747.
Otherwise, it's not. Yeah.
So
All
we
right.
have to select the option none of these. All
Yeah,
the above three answers are wrong.
What's your name?
Karupaswamy, myself.
Karupaswamy, just write an email explaining the
Okay,
mistakes in the
okay.
3 questions, and I will forward it to you. Can you see my email here? In the chat box, I have shared my screen.
I don't know how to open the chat box in my
Okay,
laptop.
I write my email now. I always, yes. Just a second. Can you see?
Yes.
Okay. Just note it down. All right.
So one more doubt, sir, whether the questions asked by participants in the forum is discussed or not. It is opened by experts or not. I want to know. So we raised our doubts in the forum.
Forum. Okay.
Will it
I
possible
don't know
to
how they are tackling it. Anyone is responding to it?
nobody responded. I asked all the 3 questions in my on Thursday, on the next day.
Oh, they should respond it. The tutor,
Okay, sir, we'll see.
the tutor who has made the assignment should respond to it. I will make. I have a tutor email. I will forward it to it to respond the questions.
Thank you, sir.
So is Shravanam? Why is he coming and going out?
I had some issue with my PC.
Okay.
Now I joined through iPad. Actually, this was Teams is creating a lot of trouble. No. Anyway, now I joined. Sorry.
Okay. Okay. Fine. Yeah. Okay. Let's start with. And let's start with some questions. So we are done with the matrices, and we now start with some other stuff. So is these types of questions are in assignment 6, Lagrange interpolation and finite divided difference method. Okay. Stirling formula. Is these type of questions in assignment 6? Okay, it's hard. It's coming not. Okay. So, what is Lagrange interpolation, and should I recall everything you have discussed in the 16? Anyway, I just recall it. Okay, I just start with that. So, what is the idea of Lagrange interpolation? Okay, so if you are given some points, say x naught, x1, let's say x2, x3, and there is a function f who has value at f, say x naught, at x1 it is fx1, and at x2 it is fx2, at x3 is fx3. Okay, so we want to approximate such type of function using a polynomial. All right, since they are like, what is a polynomial kind of? What is a polynomial? So you say that this is something. So if you have 4 points, you have the value of the function at 4 given points. And so how do you find out which polynomial best fits that data using the function? So how do you find the polynomial using that? So the question is, how many degree polynomials you should expect to get, like, for approximation? Anyone? How much degree polynomial can I expect if I
Three,
have
three.
data at 4 points?
3 degree, third degree.
3 degree, right? Because there are 4 coefficients, unknown coefficients in. Okay, there are 4 unknown coefficients in a 3 degree polynomial. And I think you have studied the proof, I don't know, in the class about how to find out the Lagrange interpolation polynomial, but I will write the exact formula and accordingly we will discuss that. Okay, so what is the exact formula for Lagrange interpolation? Anyone? Anyone remember? What is the formula?
Sir, in previous week 6 assignment, there is no lecture about Lagrange interpolation and onwards. Only previous lecture are related to eigenvalues and eigenvector. And in assignment, all the questions are related to Lagrange polynomials and other kinds.
Wait a second, I just. In assignment 6, Lagrange interpolation is there, right?
Yes, sir. All the questions related to means polynomials, Lagrange interpolation. But in videos lectures week 6, there is no any lectures related to these topics.
Okay, so what should you do if this is the case? Then you just go with the upcoming week lectures and study them, right?
Yes, sir. Yes.
Yeah, so you can do that. But everything for matrices, I'm not going to discuss. It's all done. But yeah. So those things which are very essential for exams, yeah, that I'm discussing. But those which are not so essential and can be done by anyways, this just following the definitions and all, I will not be discussing. But yeah, in this I will be discussing this. Uh, so we have discussed most of the things already, and we just move for like in these tutorials about the approximations. How do you do the approximation for a given data using some polynomials? So first of all, first is a basic method for approximation of the function given at 4 points or n points using polynomial of degree. So if there are n points, if the function value is given at n points, then you have n minus 1 degree polynomial. And yeah. So what is the formula? Anyone remember in the lectures? Okay, so you have not seen lectures. So I should recall it maybe. Wait a second, I just see that if there is some proof of it. So if you I just opened. Do you have the book Gearald and Wheatley? I'm
So I
following
am
this
ready
book.
to, sir, I am ready to give the formula for this one.
Do you know how to derive that formula?
Derivation I forgot about, but I know the formula.
Okay, you just know how to. What is the formula?
X minus x1 into x minus x2 into x minus x3 divided by, in the place of x, let us replace x naught in the denominator
I'm
and
just
multiply
opening
with
that book so that we will be in coordination with this book, but I know the formula actually. Okay, so, okay. Wait a second. Okay, so how do they derive it? Okay, so I just write the formula first. What is our saying? X minus x1,
x minus x2, x minus x3,
x minus x3, right?
and
divided by.
In the place of x,
So
we can
you
put
have
x
to
naught.
replace, yeah. Is it?
Yes. And in the numerator multiplied with the y value, that is
This is f naught,
f
right?
of x. Yes, yes. The same way we would repeat for the remaining 4 times.
So, okay, so if you have to write a general formula, say, anyway, so I don't write this. X minus x2, is it x minus x
Yes.
naught, right? Okay, so it's not 1 because it's second point. And divided by x1 minus x naught, right?
Yes. Yes,
And
correct.
so on, right? I don't. It goes on. Which last term? What is the last term?
X minus x naught, x minus x1, x minus x2.
Wait a second, I'll just.
The denominator we replace the x by x4,
x3, right?
x3.
What is the function? F naught,
NP
F1,
F3.
F2, F3.
F3.
Okay, so is it a 3-degree polynomial?
Yes.
Yes. Okay. And what is the value of P at x naught? What is the value? What are the values at P at x naught, x1, x2, x3? Is this same as F? Wait a second, I plug my charger. And yes, what is the value of P at x naught, x1, x2, x3? Anyone?
F naught, F1.
Oh, it's x naught. What is the value of P at x naught? You know,
It will be,
just
it will be
substitute
F,
x naught in.
yes, F naught. You will get F naught.
Yes. Otherwise, there is no meaning of approximation, right? If the value of the polynomial is not same at those points to the function value. F naught, F1. Okay.
Yes.
Yes. Okay, let me see something. And can I tell about this approximation? Okay, so what is the problem with this method is, okay, I will go to another method, but okay, so this is Lagrange interpolation method. Exactly one approximation method, and is a basic one. And you can see that it is trying to interpolate. What do you mean by interpolation? Anyone? Interpolation. So interpolation means to approximate the value of the function at given inside the points which are not given. Like if you are given the function value of x0, x1, x2, then we try to interpolate in between these points. Right? That what the polynomial is giving to us. It is trying to give the value of the polynomial values. Polynomial is defined on this interval and on this interval, right?
Yes.
So it's interpolation. But what do you mean by extrapolation?
Beyond this interval, outside this
Beyond
interval.
this, yes. So after x2, we try to find out the value at after what happens at if the value of the function is given from 0 to 1 at some 4 points, but you want to find the value at 2, then you use extrapolation, not interpolation. Okay. All right, so we just start with one simple question. Use Lagrange interpolation polynomial of degree 1 to approximate f of 3 if f of 2 equal to 4 and f of 5 is equal to 1. So it's very easy question, is it? So start with first one. So you are given the value of f at 2 and the value of f at 4. So f of 2 is 4 and f of 5, sorry, it is given at 5. So what is the question saying? So how many points the function value is given? 2 points. And which polynomial best fits that? 1 degree.
Yes.
Yes. So what is the formula? Tell me. What is x naught?
X0 is 2,
X1.
5.
Just substitute. So px. So I just use p1. I use p1 here because it's 1 degree. So what is p1x? X minus. Is it
5.
x minus x naught? Yeah. Is it right? No. No, it's not right. X minus 5. X naught minus x1. So x naught is 2. Is it right?
Yes.
And
Into
x
4.
minus.
First
Oh,
term multiply
sorry.
with 4.
Yeah. Oh, okay, sorry.
Minus
F of
2 minus
f naught
5.
is 4. Yeah, this. And x minus 2. This is 5 minus 2. Am I right?
Yes, into 1.
And it is 1. So what is this? 4x. What is the answer? So it is. What is this? So you can just solve it. I don't know. 6 minus x. And you have to calculate the value of the function at 3, right? Value of the polynomial. So what is p13?
3.
Yeah, so what is the approximated value at 3 of the function is 3 using this polynomial. So it's just a simple one. For the given function, if we construct Lagrange polynomial of degree 2 to approximate this, find absolute error. All right. So what is the absolute error if we use, what do you mean by error? Anyone? I go back to this definition. What do you mean by error in this case? What do you understand when I say error? What is absolute error? Tell me.
Modulus of actual value minus
Approximate.
obtained answer.
Yes. So here, why I'm saying about error, what they are saying about errors. Is it like, okay, so you are given the function value at 4 points.
Yes.
And you are given the polynomial function. You are given the approximated function, which you are saying it is a polynomial. So you have to calculate the value of the function at, say, some precise point. Let's read the question again. So for the given function, so what they are saying, the function is already given to us, right? And function is already given to us. So this function is defined from x0 to x2, where x0 is 0. Oh my God, what happened? Why the people are coming? Okay, so x0 is 0 and x2 is 0.9, and under root of 1 plus x is defined from 0 to 0.9. Anyway, it is defined over all positive x and x greater than -1. Is it defined everywhere? Yeah. So for 1 plus x greater than 0, this function is everywhere defined. And you know the value of function from 0 to 0.9. So you know the value of the function f at 0.45, right? So we need to find the approximate value of f using the polynomial of degree 2, because there are 3 points. And then what you have to do, you have to calculate the difference between the value of the function f at 0.45 and the polynomial value at 0.45. All right? You understand the question?
No, sir, it is not that way. First of all, it is given
Okay.
x1, x2. Respective f0 values we got to obtain from the square root of 1 plus x function.
Yeah.
Afterwards, we got to apply Lagrange's interpolation method
Yes.
to get a polynomial. From that polynomial, we got to get the answer for the f of 0.45.
Yes. But no. F of 0.45 is already given to you. You don't need to calculate the f of 0.5 again. F of 0.5 is function value f at 0.5. And the value you calculate from Lagrange interpolation is the approximated value, not f.
So you are discussing question number 2?
Yes.
Sir, question number 2, the function f of x is given as a square root of 1 plus x.
Yeah, it is already
so
given to us.
that function is given only for finding the y values, f of x values.
Yeah.
F of x values at 0 and 0.5 and 0.45.
But you need to calculate the approximated value of f also, right?
Yes.
If you don't know the value of f at 0.45, you need to find out the approximated value.
Yes, of course.
Then how much is the error between the actual and approximate? That is given by absolute error. You understand?
The original f of x formula, we go to substitute 0.45. That is the actual answer.
Yeah.
After generating Lagrange's interpolation polynomial, we will get a secondary equation. In the secondary equation, we go to substitute 0.45.
Yes.
That is the approximate answer. The difference, the absolute value of these two is the error.
How much they are deviating, and do you understand? So how do you do this now? Okay, let's discuss this again. But it's just an easy question. So I just write the function and you tell me the correct polynomial. So second, f of x is root x. And everyone do the x0, x1, x2. What are x0, x1, x2? 0.6. Okay. And what is f0? F0 is
1.
F1
1.2649.
what?
1.2649.
1.2649. What is this?
No, sir. Square root of 1.6 is not 0.4.
Oh, sorry. Yeah. 1.26. What is the square root of 16?
Yes,
You can
1.
write 2649. Yeah, it's 0.16. The square root of 0.4 is, oh sorry, 0.4 square is 0.16.
The next one will be 1.3784.
Yeah. So anyways, whatever the values, but the point is, how do you calculate the approximated? So you can use Lagrange interpolation.
Yes, of course.
Just find out the polynomial and tell me what is the polynomial. Okay.
But it will
Either
take
you
time.
use
It will
either
take
you
much
use
time because the
MATLAB to
numbers are,
find out.
yes, numbers are decimal numbers.
Yeah. So you can use MATLAB for the time being and to find out the interpolation formula. Okay. Or you can solve by hand calculations. So what is P2x? Okay, what is P2x? Just find out this first. I'm waiting for 5 minutes. Yes, anyone? Okay, let me. Anyone solved it?
Not yet solved.
Okay,
Takes time.
just try.
X minus x1.
Students are there. 10, okay. So
A minus. A minus. Minus x2. X2 x3 minus x1. X1. X3 minus x2. X3 minus.
okay, so let me down the formula for it. 530. Yeah, so I directly write the value. Okay, so 0.06. So P2 at 0.45 is just 1.20341. You just check. So once you got P2, the approximated value you can. Okay, so what is the F.45? What is this? Square root. One point two zero
1.20412.
416. So what is the difference? You can just calculate, right? Anything like difference. I'm not going to calculate it. Anyway, so that will be the difference and it will give you the absolute. Okay.
Just
This is
actually
easy.
one small clarification. This
Yes.
formula what we are looking is like this. Just I will confirm once again. X minus x1 into x minus x2 divided by x naught minus x1 into x naught minus x2 y naught. Like that we have to do y naught, y1 and y2. Correct, na?
Yes.
So that will give us the directly in terms of an equation with the second degree.
Yeah.
Okay, and finally we have to solve for that x equal that okay. Then if it is x means Equal, we have to equal to 0 and solve for x.
No.
No. We're going to get the value of f of 0.45 in the polynomial.
Okay, directly put that 0.45 in the polynomial. Clear? No,
Yes.
clear. Okay, clear.
Okay.
Fine. Yeah, because that equation is going on. Probably I will just substitute and look later. No issue. Thank you.
So this is what you call as manually calculating absolute errors, and there is like exact expression for absolute error in this case. And okay, I can show maybe book. Let me see here. Can you see the book?
Yeah. What is the title? Saying numerical analysis by Jane?
Gerard Wheatley.
Okay, Wheatley, right? Okay.
So I just write this, whatever is this given to you. Okay, so here it is, the expression. Wait a second, it's not there. So I just explain it. This one, do you see this? This expression I've written is already. Anyway, so you try to do in MATLAB also, right? How to find out this? Okay, so
is said to it. Yeah, that particular coding is said to be that means given in the lecture series.
this same coding.
No. Actually, we are yet to see that lecture series. Now up to 6 week only it is uploaded.
Okay.
So week
Yeah,
6,
it
we
will
are
be
yet
there.
to. Yeah. But maybe next week we may be getting it.
Yeah. But for the assignments, you need to practice. Means what I'm doing today is I think this all will be covered in assignment and you can do that.
Sure. Yeah.
You don't need to see the lectures, I think, for that.
Correct. But still we have time only up to Tuesday. This
Okay.
will, I think these lectures will come by Monday only, the loaded new lectures.
Okay. But they are available on YouTube, is it? No.
Sorry, for
Already available if you want to see future
okay.
lectures recorded
Okay.
there.
Okay. Fine. Got it.
But for the assignment, if you want to learn, then you can just follow me and in the tutorial what I'm doing, nothing else.
Okay. Fine.
So error of interpolation. So how do you find the error, exact expression for error? So I just go through with a small proof for it in this book. So you have this function, right? F of x and p n x, right? So we denote the difference between f and p and x as e of x, okay? And you know that x minus x naught, x minus x1, and x minus xn divides this f of x minus p and x. Why? Because f of x naught is the same as p and x naught. They are the zeros of x naught, x1, and xn up to xn are the zeros of the function e. So their respective linear degree polynomials x minus x naught, x minus x1, x minus xn divides fx minus p and x. So we can write down f of x minus p and x as some multiplication of these functions with some another function, say gx. You understand this step? And yeah, because this is already done because fx minus pnx is ex and fx minus pnx minus this is also equal to 0. So what they do is they try to rename a new function wt, which is same as f of t minus p and t. They replace x by t, just nothing doing. And the gx remains same, except. So what they do is they try to calculate the n+1 derivative of w and put it to 0 because it's just a polynomial of degree n. So its n+1 derivative will be 0. And hence you calculate this expression, you put it to 0 and you just calculate that gx is this. So particularly what they are finding, this gx term in error expression, ex is the error. All right. So this is the, what do you say, it is the error between the approximate solution and exact solution, actual solution. Sorry, exact function value and approximate function value. Do you understand this one?
Yes, sir.
But you remember this expression. So we are going to use this expression maybe in the second question. Okay, let's see that. For the following, okay, third one. Let f of x is this and p2x be the interpolation polynomial on x0 and x1. Find the largest value of x1 for which f.5 minus p2.5 is minus 0.25. All right, so what is the largest value of? Let me see the question. So you try to calculate f.5 and p2.5. Okay, so now can you solve it? Anyone? Third question. So f.5 minus p2.5 is minus 0.25. What is the largest value of x1 for which this happens? What is this? Minus 0.25 is what?
The error.
Yes, it's the error, right? E at 0.5, right? And do you know the expression of error that I have just said? What is this? E.5 is what? 0.5 minus, what is this? 0.5 minus x0, 0.5 minus x1, and f double dash psi by n+1 factorial. So what is n here? It's 1. So 2 factorial. Am I right? Yeah, so you can see this one. There are 2 points. Oh, so there are 3 points. Sorry. So wait a second. E.5 minus yes. And you know the value of what is the x0? You know x0, you know x1, you know x2, you know f double dash. So what is f dash? Fx, right? What is f dash x? Am I right? What is f double dash x? Is minus 2 plus 1 minus 2x. Yeah, so you know this type of expression. And so what do you try to do in this case? You know f double dash psi now. So E.5 is minus 0.25. and you have the error. Okay, so what is the bound on f double dash psi? You have to find a particular bound on it. Once you find a bound, then yeah, so what I would suggest in this case is that, yeah, so I would suggest in this case, the error expression is making us difficulties, right? So you just try with the normal definition. I don't go with the error because finding the bound is quite difficult. Difficult. So what I suggest is to solve this question, you just use.
Sir, I have another option.
Yes.
So for the given data, we can find the f of x.
Yes.
Secondary equation.
Yeah.
This function will be maximum or minimum that we can use with the help of f dash, f double dash. We can.
Can you find out the bounds on it?
Not bound, but we can find the maximum value, maximum difference. So what's the question
Maximum
asked
of
is
f double dash.
whether f double dash is asked.
Yes. In the error term, you have double derivative of f. So you need to bound it.
Okay.
So
But
it's
the
not
differentiation
easy.
is a small mistake in f dash of x. There is 1/2 will come.
1 minus 2x and yeah. Okay. And hence so it's quite complicated to find the bound. So I would suggest you to find out the function approximation using the normal method and just compare the difference like you done with the earlier question manually. That is far easy. That is much easier. Understand?
Yes.
So it's just but you sometimes you need this definition. I'm not saying every time you need to use this definition. You can use this definition. Yes. But if the function is so like easier to bound or the function is not so complicated, it is just the double derivative is just constant or just a linear function, or you can see that clearly. Yes, what are you saying?
Can you please just clarify the other method? Like this one is okay. The other method is what we did now, the same thing.
Yeah, we have done in the previous question. Do you remember?
Okay. So there we have, yeah.
What we have done in that?
The same like 3 degree. Like this will be like
Yeah.
1, 2, 3. Yeah. Okay, fine.
Here, just calculate the difference. Just calculate the value of error at particular point that you can do. And find out the value of x1. Just simple it is. Just find out the value of x1.
Okay.
Because this, x0, x2. The only thing that you don't know is x1. And you don't know the value of function at x1. Right? So ultimately you will end up with a cubic equation. I think so.
Correct. Yeah.
Okay. So it will give you the exact values of x1, which satisfies this. Anyways.
Okay.
Yes, divided difference. So okay, so this is different topic. Yeah. So we are going with divided difference now, and let's see what's in the book. So this is the error approximation. What is the form? What is the problem in this method? Can anyone tell me by looking at the method?
It is another type of interpolation formula, interpolation technique.
Why we need more types of interpolation formula? What is the problem in this method?
It is alternate method for Lagrangian method. It is for unequal interval. This will be used.
Unequal interval.
Unequal intervals. If x0, x1 X are not equally spaced, then we can go for divided difference.
If they are not equally spaced, no, we can
Yes.
just use Lagrange interpolation.
Lagrange and divided differences both are used only for the unequal intervals.
Okay, for equal intervals.
We have another methods, Newton's forward difference. Newton's backward
Why we
difference.
can't use Lagrange interpolation for equal intervals?
It is also possible. It is
But
also possible.
why divided difference? What is the use of it?
Divided difference calculation wise, Lagrange's will take much time. This method will we can get the answer quickly. So in the Lagrange's method, if the number of input is more than 3 or 4, our obtaining the polynomial becomes a very difficult one. Here, after finding the divided difference, we can easily get the polynomial. This method will.
We also get the same polynomial, right?
Yes, of course, same polynomial. We got the same
so
polynomial.
What is the difference?
Here we.
Okay, so you are saying calculation wise to find out the polynomial is difference, is it?
Yes, Lagrange's
so why it
method
is coming? Why there is less calculations in a divided difference? Okay, so here you see that you can see that in the Lagrange interpolation there is one big problem. Yeah, so yeah, that all that you said, that arithmetic operations are more than the divided difference method. And another problem, that is one problem. Another problem is that if you want to interpolate at a new x value, okay, then you need to construct the whole polynomial. We have to start with all the computations again, but it doesn't happen with divided difference. So if we want to add a point in Lagrange interpolation, what happens is that, just look at this method. If you want to add the point, let's say, so this polynomial, you see, this takes x1, x2, x3, x0, 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 x0. Okay, so x0, x1, x2, x3, and the value of function at x. So every point is included in the first expression. You see first component. Now you tell me what is the problem. If I want to include x4.
One more factor in the numerator and the denominator we got to add for all the terms.
Yeah, so it's like you have to change the whole components. So it's not too good. You need to change the whole components and you have to reconstruct the polynomial. You can't take the help of your previous polynomial. I can't just add something over here, some epsilon, and change my.
The same problem will also arise in divided difference also. We cannot insert a point after this solving the problem.
So,
if you
okay,
if
let me show you. Let me show you. Wait. So the divided difference polynomial is this. You have this one, right?
Yes.
So here you see, if you have x4, then this is the first component, and it doesn't have any x4, right? So
of course.
So in this call, so in second component also you don't have x4. In third component also, fourth component, fifth component. In sixth component there will be x4. So you don't need to change the whole terms. You don't need to change all components.
Of course.
That in case of Lagrange interpolation, you need to. Yeah.
When we are going to find out the f of x0, the second last factor of each term, that will be changed.
Yes. Everyone got this thing?
Pardon?
Not clear here. Not clear. Probably the earlier one is clear. Yeah. Here actually one other term we need to add one more exponents. It becomes more complex. That is one point.
So I just explained it. I just explained why, right?
Yeah.
I think. Okay, so let us start with some small problem. X0, x1. You are given the value of function. This is the old data. All right. You have two values.
Yeah.
So what is Lagrange interpolation? What is this? P2x. What is this? X minus x1, x0 minus x1, f0. X minus x0, x1 minus x0, f1. Right?
Yeah, clear.
It will be P1 of X.
What?
P1 of X, not P2. Left hand side.
Yeah. P1x, right. And what about the, yeah, so this is all data. And let us write Newton's polynomial, Newton divided difference, that I have not told you, but what is this? F of x naught. Am I right? Right. So f of x naught plus x1 minus x naught, f of x1. So it is f of x1 x naught. I think so. If you go back to see the definition, yeah, it is x naught x1. And the definition of x naught x1 is? So what is f of x naught x1?
That will be F1 minus F0 by X1 minus X0.
Yes. Yeah. Is it right?
Okay. Yeah.
So if you see here the definition of, yeah, so yes. I think there is there. Yeah, so f of xs, xl, xt is ft minus fs by xt minus xs. Okay, so what's the formula? It's the name. Yes. And it is x minus x. Sorry, it is not x1. All right, so this is all for all data. Okay, now I change the data. Now I change x1. Okay, let me write new one. New data. What is new data? X0, x1, x2. Okay, I write. So using this new data, what is this? Newton divided difference. So this term I added. Tell me, what is Newton divided difference?
But P1 of x or P2 slightly directly we can write P2 of x here.
P1 of x plus x minus x0, x minus x1. Right?
Yes.
So I have used this previous all data. And what is Lagrange? Can I use all data now? All data polynomial now? Yes, Shravan.
Not possible.
No, not there. Yeah.
It's not possible.
Okay, clear. Yeah.
So yeah, you can't use. So it's like you have to reconstruct. Reconstruct. No dependence.
When we
So
say the
that's
old and when we say the old and new data, we are adding one more point. Is it like that? Like just one more interval, if it is getting added, it will be easy to find from that old data rather than doing everything full. Is it that way?
yes.
Okay, okay. Whereas Lagrange is everything we have to redo in full.
Yes.
Okay, clear.
Quite complicated to do stuffs again. Everything, the same thing, and Anyway, so let's discuss the divided difference. So I will discuss from this book. Okay, so you are given a table, right? At these points, and these are the function values f0, f1, f4. So how do you calculate the divided difference? This is the first divided difference, second, third. So how do you calculate the first one? You just try to calculate f1 minus f0 by x1 minus x0. Fx1, x2 is the second divided difference, which is f2 minus f1 by x2 minus x1, like that. So you just calculate the difference of these two, difference of these two, difference, and these you will get. Then difference of these two, and then divided by. You understand?
Yes, sir.
So you can do this, I think. Let us start with some questions. Yes, so for the following set, find the second divided difference involving 1.6, 1.9, and 2.2. Okay. Wait a second. So they are saying using involving 1.6, 1.9, and 2.2. So I just start with. Okay, so how do you do that? If you calculate it from here, 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 here. Then you get 4 values, and using these 4 values, you get that, 3 values. So first and second. So, okay, so 1.6, 1.9, 2.2. So you get these 2 values. This is the first one, and you get this value. Is it right? Am I right?
Can we do one?
You
Solve
understand
one.
what I'm saying?
No, actually, like one is like difference you are referring to.
This is the first one.
Okay.
Using 2 values that I showed, right? One using 1 and 3, you get the first divided difference. Using these 2 points, using 1.6, 1.9, 2.2, you get this first one, right? With 2 points. And then using these 2 points, you get second one. So how do you calculate now? Tell me. I just do it here. So I just calculate the first divided difference, that is, say, f of 1.6, 1.9. Tell me, what is the first divided difference? Okay, let me write the whole. You just calculate it and tell me. I think in the lecture they are not dividing, but you confirm it first. Okay, calculate this and this. Okay, I write this one. You substitute the values yourself. Can you tell me the expressions? So this is first divided difference. Okay. Tell me what are these values? Yes, tell me. I'm waiting for 2 minutes.
First one is minus 0.578612.
Okay, so what is the value?
First one is minus 0.578612.
And second one?
Minus 0.571512.
Okay, now calculate second divided difference.
Yeah, let's also confirm that values since it is done in.
Yeah. So what is the second divided difference is just, how do you calculate it? Let me know. So yeah, so you go there and you see this one. So second divided difference is x0, x1, x2. x1, x2, x3 using these 2 points and using these. So x2, x3, x4. So it is just f of x0, x1, x2 is just x1, x2 minus x0, x1 divided by x2 minus x0. So it is, so what you have to calculate 1.6, 1.9, 2.2 f of 1.9, 2.2 minus f of, is it what? 1.6, 1.9 divided by 2.2 minus 1.6. Now you tell me what is this value? That will be the second divided difference and your answer. If they are taking this way, I'm not sure. Just subtract and divide by 0.4, 0.6. Okay, so what is the value? So it will be 0.0, 0.7. Am I right? What is the sum?
0.0118.
118?
Just one second, let me recheck.
Yeah. So B is the right thing.
Yeah.
Okay. So you understand how I calculated them?
Yeah, just know that only one doubt. We have
Yes.
this many data points 1.6, 1.9, 2.2. We have concentrated only these points.
Yeah.
What about the left side points?
No, they are, the question is saying, what is question saying?
Okay. Only with that 3. Okay. So if
Yes, you can calculate in similarly.
okay, if all data sets are involved, like how to start like second difference, whether they will ask that way like 1 to 2.2
Yes.
full data points.
Hmm.
If that is the case,
You can go to third divided difference also
okay.
and fourth also.
Okay.
But as you move on with the divided difference, you know, the points will decrease.
No, just to
Ultimately,
clarify from my side, say if, for example, one is having that we can take as F1, last one is F 2.2. So I
Yes.
have to start between these two first.
Yes.
Okay, one and the final. Then I have to slowly reduce the points and
Yeah.
add
You
out.
need to use these triangles and
Okay, triangles. Okay,
I
fine.
just really
Thank you.
the following. Okay, so if it is clear, then we can move towards next one and we will discuss what the Newton forward difference is also maybe. Okay. So the following data are given for a polynomial of unknown degree. Determine the coefficient of x square if all third order differences are 1. So, okay. So if all third order differences are 1, this question makes sense. No. Third order Newton divided differences are 1. Things. Yes, so you can just do that. I think in the way that, how do you do this? Anyone? It's just a vague question. I'm not. Yes. If all third order differences are 1. What the question is giving you? This is Newton divided difference. Tell me the polynomial. So 0, 1, 2, 2 minus 1, 4. So you have f at 0. Right? So what is Newton divided difference polynomial? Yes. It's f of 0 plus f of 0, 1 x minus 0, right? Of 0, 1, 2. Right? And they are giving that. And this is given in the question is that if all third order differences are 1. What is this? The question doesn't make sense to me. Third order differences means this is should be 1. And you get x square minus x. So x square coefficient should be 1. Yes, so none of these. This is not a good question. We now move to next one. The Newton forward difference approximation formula is used to approximate for the following data. Suppose it is discovered that f.4 was understated by 10 and f.6 was overstated by 5. By what amount should the approximation to overstated and understated? Why do you use this type of language? Approximation to f.3 be changed. Under means they lower this by 10. Made higher. Okay, so you just use the the Newton forward difference formula. They are naming it separately. Newton backward difference, forward difference. Okay, let me see what is this. We are having forward difference, backward difference. So this is the forward difference formula, and this is Newton-Gregory polynomial. Yeah, so okay, let me check it. What is the forward? Why they are naming it differently? Newton forward difference. Yeah, so this is the Newton forward difference formula, Newton-Gregory polynomial. I'm just writing this one. Okay, it's quite complicated. Okay, so we have this f naught plus sf naught. S is What is S? S is basically x minus x naught by h. So this is the what you called as forward difference formula in this case. Yeah. It is del x. So anyone who have to, someone was talking about the grid points. So if they have equally spaced, if the grid points are equally spaced, then we can reduce it to this type of formula. Okay. If the grid points are equally spaced. Okay, let me write down and solve one question over this. So we are talking about the forward difference formula. Okay, so Newton forward difference. I'm not going to discuss so much, but I'm writing the formula and some questions like some random question. Yes, so here it is F naught plus S del F naught and SS minus 1 by 2. Sorry, it is, I'm not sure. And so on. Anyway, I'm going with this point. This is some kind of it will be 2 degree polynomial and this is p2x. So okay, let's to see how to use this formula. So you are given the value of the function. I'm just going with some random examples. So 1, 2, 3. You are given the value of the function at 1, say f of 1, f of 2, f of 3, right? So how do you calculate del f naught? This is f. How do you calculate del f and del 2f? So del f will come from this, which is f2 minus f1. So here, if you see here, then how they are calculating del f? They are just subtracting these two values. Forward means, what is forward difference? Means you just take this value and you just subtract it from this value. Then you get del f values like this you do for the rest of the things. So here you have f3 minus f2. And del f1 is just a subtraction. I'd say it is say y1 and y2. So it is y2 minus 5. So this is, sorry, this is 2, del 2. You understand this? How do I calculate it? Yes, tell me. First, this step. Yes, Shravan. Anyone?
Yeah, I think we are directly going with the difference of these functions, right? Like we have to find the interval between these two functions every stage, each stage.
Yes.
That will then substitute that values in the above equation.
Yes, yes. Yeah.
With the factorial. So it is like we have to find the intervals and substitute in the above equation. And each
Yes.
stage we are increasing this del f and del f square, del square f. Yeah.
Yeah. Okay, let's try to solve. Let's try to find an expression using this. Okay, so here you have start around. We must use the 4 entries beginning with x equal 0.4. They are using. Okay, so they are trying to calculate at 0.73. Okay, so here is the formula and S is x minus x naught by h. So what is S here? So depending on what is our x naught, we can define S. All right. And h is, what is h here? Anyone? H is the step size. What is this? 1. So it is just x minus x naught. So what is the formula? P2x is just given by f naught, which is f1 plus s. S is x minus x naught del f naught, which is f2 minus f1 by h plus x minus x naught s minus 1. S minus 1 is what? X minus x naught minus 1 divided by 2 into del 2 f naught. So you know how to use this formula now, everyone? How do you use it? You have to choose x naught. Like in this question, I just repeat it here. Okay, so they want to find out the value at 0.73. From this 0.73 lies after 0.6. Okay, so they are using the 0.73 value. In order to center the x values around x equal point, we must use the 4 entries beginning with x equal 0.4. So what you need to do, if you have to start with, you have to find out the approximate value of 0.73. So this is coming through before 0.4 and 0.6. You need to make 0.73 in the center. So how will it come in the center? To make it in the center, you need to take points from 0.4 to 1. Or you take 0.6 to 0.8, depending on what type of polynomial do you need. So they have taken from 0.4 to 1, and 0.4 is, yes, so they have started from 0.4. They have taken x naught to be 0.4. Using x naught to be 0.4, you can easily calculate s. Here h is 0.2. You have x naught 0.4, and then you can just use the expression to find out the values. Yes, anyone? What is the problem? You understand this? You understand this formula?
Yeah, formula is okay. Just to now we are telling that we are finding between this interval of 0.6 to 0.8. Yeah, 0.73
Yes,
is
yes.
in these two intervals. So they have started
Yeah.
with 0.1, 0.4 to 1. We can even go with 0.6 and 0.8 also. No?
Yes,
Like,
depending on the polynomials.
okay, okay. So now whatever the question they have asked, is it the similar way? Like,
Yes, yes. Let me see. Yeah. So we have 4 points and 0.3. Yeah, they are asking at 0.3. So it's easy.
okay.
You have to take 4 points.
So all 4 points are 0.2 to 0.4 itself is good enough.
For the suppose it is okay. So what they are saying is that they are giving some conditions on 0.6 and 0.4. They are changing the values, so you have to use 4 points. But they should mention, like if they are giving this whole table, then you just use whatever the whole points, whatever are given. If they are giving just, if they are saying to find out polynomial of degree 1, then they just has already given you 2 points. But here 4 points are given, so use them.
Okay.
Okay. Okay, so likewise you have Newton backward difference formula to approximate F2 for the following data. Okay, so let me see what is Newton backward difference. And this is not given in the book. Yeah, so Newton backward difference is like this. You just go some questions, write some questions from the books. So the Newton backward difference is like, okay, so if you have to calculate, like in the previous table, you have F0, F1, F2. Now you have to calculate this sign, you remember, No. So you, instead of finding from F1 minus F0, just calculate the difference from F0 minus F1, F1 minus F2, and this difference, Y1, Y1 minus Y2. Okay. So, and this is the formula P2X is F0 plus S del F0 plus SS minus 1. It is SS plus 1 by 2 del 2F0 plus. If you want to add P and X, then it is SS plus 1 S plus N minus 1 by N factorial del NF0, where S is X minus X0 by H. H is del X0. H is the grid size. So you understand this question? This formula, sorry. It's like similar one. It's just same as that.
Only thing we are taking a difference from like it is not from F1 minus F0, it is the other way, F0 minus
Yeah.
F1.
Just other way around.
Can you
And
just
here-
can you please scroll down just that note down
Okay.
that language. So this last one is not clear, that S into S plus 1 minus of S minus N minus 1. The
Yeah,
P
if you're
and
finding
X.
N degree, I'm writing for N degree.
Okay. That's yeah, minus is minus of S minus N minus 1. Is it correct now? The bracket, whatever written?
Yes.
Okay.
It's S plus N minus 1. S
Okay,
plus.
S plus N minus 1. Okay.
Yeah.
Whole divided by N factorial.
Yeah. So you
Thank
just
you.
practice them. If you don't practice, I
Correct,
you need to
fine.
practice questions regarding that. I can write only formulas. If you don't practice it, then you will not get it. If I explain it.
Yeah,
So
got
these
it.
formulas are like that.
Yeah.
Okay.
Yeah.
So not going with this. Stirling formula. I think there is no question in assignment 6 regarding Stirling formula. So I just skip it for a while, skip it, and we will do it next time. But it's just an approximation formula, and I will ask you if you want what you got it from it. It's like similar to the divided difference, kind of. Yes. Now, the relationship between E and DAL is. Do you know these E and DAL? Have it been discussed in lectures?
No,
Do you know
sir.
this? No. Okay. So, okay. So E is basically. Okay, let me write here. So suppose you have given function at x, then E of fx is fx plus h. It is just shift by some h. H is the step size. Grade of step size. Okay. And what is del fx? Fx plus h minus fx. So what is the relation between E and del? Tell me now. Anyone? Which option is correct? Which option is correct? It's easy, right? Just calculate E of f of x and just calculate 1 minus del of f of x. What is 1 by 1? Is the first
Okay.
option correct?
Is it del minus 1 C?
So C is correct, you are saying. Let's check it. So E, yeah. So del minus 1 is f of x plus h minus f of x minus f of x. So it's just, no, it's not correct. Is it same as E? No. It's not correct.
We are having f of x hs.
B B
Which is correct?
B.
B. Yes. B is correct. Check it. 1 plus del f of x is just f of x plus h. Because f of x will cancel out. You got it, Shravan?
Yeah. Can you please show that equations like what you have written the other
Mhm.
way? Yeah. Just yeah. Here just above. One more few lines. Yeah. Del fx is f of x plus h minus fx. Okay. Correct. That is clear. Then del minus 1 is f of x.
You got it?
Yeah.
Okay. So can you do this in the similar way? Everyone? The last one. So what is del of x plus cos x? Tell me. What is this? So it is x plus h plus cos x plus h minus x minus cos x. Am I right? This is x. So you see this. X got cancelled. And you have so it is like right? What is the answer? H is 1. So it just replace 1, 1. So it is,
Can you please show the question once?
yes. Why Mayuresh is coming and entering again and again like that?
Yeah, clear. Thank you.
You understand, everyone? So it's done. So yeah. So I will share this tutorial sheet, but now, yes. So if anyone has any questions, can ask.
So there are some other relation in assignment. Question number 2. Other
Yes,
than
yes.
delta, please explain that.
Okay. Which expressions are there? They were in the lecture. Okay, you have not seen the lectures. Which question number?
Number second. Question
Okay,
number second and question number first, please also.
okay. So in general, okay. Yes, so if you have like EM, FX, do you you mean by this one? Okay, I'm not shared my screen, sorry. Just shared. Yes. So if you see this one, then it is f of x plus mh. Yes. So this is the first question, I think. Yes. And
Sir, there is a relation between e to power m into e to power n something.
so you have to solve it. I'm not going to solve it. I just written the expression for it. What do we mean by e to the power n?
Okay, sir. Okay.
Second one is del fx, which is f of x plus h by 2 minus f of x minus h by 2 e half. I think this is the thing, right? And what is mu of x? Why we are using some stupid symbols? By 2. Yes, anything else?
No, sir. Thank you.
Okay. Yes. Anyone has any doubt?
Sir, please show slide previous slide again. Just 1 minute.
You have not saved it or? Okay, right down. I think you will be able to do the assignment 6 now.
Sir, in last expression, mu fx is equal fx plus h by 2. Is it correct?
Yes.
Okay. Fx plus h by 2 plus fx minus h by 2.
Wait a second. Yeah, it's correct. It's kind of calculating the average, right? The average of two values. Mu means average. Mean you denote by mu or? It's done now. Anyone has any questions?
Sir, in
Mayuresh here.
Yes,
Yeah, please go ahead.
Mayuresh.
Anilji, please go ahead. I'll ask later.
Okay.
sir, question number 5 is same which you have done just in previous assignment, question number 5.
Wait a second.
Or this is different from other.
It's no, it's just uses the error function, error bound.
So what is the main truncation here?
Truncation error. Truncation error is just the error, absolute error. In this case, in Lagrange interpolation.
Okay, means question is same which you have done.
Yeah, you
earlier.
need to find the bound on the error. And you need to know the double derivative function on the bound on the double derivative of function on that interval. Yeah, it's quite same.
Okay. Thank you.
Yes, my
Probably you have gone mute. Yeah.
Yes. You're asking?
Am I audible there?
Yes,
I'm not able to hear anyone.
You are audible. You are audible, Mayuresh.
Mayush, you are audible. Please ask question from sir.
I think his mic is having some issue. Mayuresh, you can post it in the chat box, right? I think you are
not
trying
able
to speak.
Hear anyone. Let me log
Yeah,
in.
now only it is coming. Mayuresh, you can. Okay.
He'll have to look at it.
Yeah, I think probably one small question, SG, actually, with respect to that last assignment,
Yeah.
probably the spectral radius, I think we would have discussed. The roots are like three roots we are getting for
Yes.
that particular equation. So one of the root, that highest magnitude root is like 7.7332.
Am I
Other-
audible, Yash?
Yes, my wish. Yeah.
Yeah, so that was one query. Actually, probably that particular value was not the correct answer. Actually,
Yeah,
three
yeah,
values.
that was wrong.
Yeah. Okay.
You just email. I've said already in the starting.
Okay. Sorry, I could not having some connective issue. But anyway, I posted in that other group group
Yeah,
for that.
Just
Yeah.
paused. Yes, my wish.
Yeah. So actually, just it is a completely non-technical doubt. Just wanted to know. I was not not a part of first discussions, whatever would have been happened. Just wanted to know this assignment. No, is it an intentional next week assignment given to us? Next week's content assignment,
Yeah, it's like
or
I
is it
think
by
so
mistake?
that I don't know. They are
No,
giving
because
like
this
that.
week's no questions have been are not there at all.
What is being discussed in this week? Can you tell me the topics?
I'll tell you.
Yes, like
There are,
eigenvalues and eigenvector.
Eigenvalues by inverse power method. Power method anyway. One question was there earlier, but inverse power method. Then there is one more.
Yeah. These not
Russian,
discussed
G.
here. So accordingly, I have made according to the assignments the way they are doing. But yeah, it's right. They should give it by week to week. But you can see these
There is one,
YouTube
Gersh
videos are
scoring
there.
method. Yeah. There is one Gersh
Gersh
scoring
scoring method,
method.
yeah. I should maybe sometime I can take extra class and we can have discussion with power method, inverse power method, and Gersh scoring methods.
Yeah. So there
Because
are no
my 1
questions at
hour
all
was already
from this.
missing before, so I want to take 1 hour class sometime.
Yeah.
Okay, but
In fact, I have
whatever,
requested for yeah, it was written in the forum also that we have written in a forum that this assignment doesn't matches with the content, but there is no reply.
Oh, there
We
was
can
no
go
reply?
through YouTube videos, no issues, no reply.
Oh, so I just email the respective tutor and
Yeah, can you please do
he
a
should
favor,
answer me.
please? Yeah.
Yes. Okay.
Sir, I have also a little doubt.
Yes.
Sir, when we talk about a spectral radius of any matrix, then it means directly we find the eigenvalues and we select the largest eigenvalues in magnitude, or first we change the matrix in the form of H, and H is equal D inverse L plus U, then we calculate the eigenvalues and take the largest eigenvalues.
Yeah, okay. You just try to find out the eigenvalues of H.
So in assignment question, we have to find the eigenvalue of A or eigenvalue of H in
So
previous
if
assignment.
if you have to find, if the question says that you need to find out the spectral radius of a matrix A, then you just find out the maximum absolute eigenvalue of that matrix A.
Means there is no
That,
need of H.
Yeah,
no,
no
but
need
that's
of
the wrong
H.
answer. I got a wrong answer in that.
Yes, it's wrong. Question is wrong. Means
Oh,
so sorry,
question. Okay, that
answers
is
are
wrong.
wrong.
Is it?
Options are
Answer
wrong.
is wrong. Okay.
Yeah.
Good.
And so second question is, sir, can we use MATLAB in exam?
No, you are not allowed.
So how
Otherwise, how you will do all the questions of MATLAB by just doing in command window?
then sir, how we calculate the long question means?
There
So
should
there are,
not be long questions. There should be like easy questions. It will be solved by hand. But you need to use calculators.
okay, sir.
just practice. Is there any online calculators like online calculators that are given in exam? Can you practice at home like that similar one?
No idea. Yeah.
If you can arrange it, because it's very helpful. You don't need to go in exam and just see where is the button and all. You just try to practice that type of calculator in your home and do the assignment questions using that, so that your speed mix will become good.
Okay, sir.
Yes, anyone? No. So I can stop now because it's already late. Thank you.
Thank you.
Yeah,
Thank you, sir.
thank you.